The recently unveiled leave schedule for Room specialists hints at the deployment of our cutting-edge $101 billion spacecraft. If all proceeds according to plan, we may initiate our journey ahead of schedule. The mission to Proxima b is estimated to take roughly 20 years. However, in reality, it will likely take several more years before we can even begin verifying whether life exists on that distant planet. The question of whether humanity is truly alone in the universe remains open, driven forward by the remarkable discoveries of the James Webb Space Telescope, JWST. This instrument has already uncovered astonishing cosmic phenomena that may bring us closer to answering this age-old mystery. For centuries, the search for our place in the universe has captivated humanity, inspiring countless stories, scientific theories, and technological advancements. Our deep curiosity and inherent loneliness have fueled our desire to find others in the cosmos. Though we are but a small part of the universe, we may now be inching toward answers that could forever change our understanding of existence. But one must ask, are these the answers we truly seek, or could they be truths we are not yet prepared to face? Join us as we explore groundbreaking developments in astronomy and exoplanet research, a journey that may ultimately confront us with realities beyond our current comprehension. In 2021, scientists achieved a major milestone, possibly one of the most significant in human history, with the launch of the James Webb Space Telescope. One particularly fascinating question emerged. Could our technology someday detect artificial light on distant worlds, such as Proxima b, the closest known exoplanet to Earth? Proxima b, located approximately 4.25 light-years away, is believed to have one side perpetually in daylight and the other in darkness, similar to our moon. Scientists hypothesize that a technologically advanced civilization living there might use solar panels to collect energy on the day side and transfer to the night side using photovoltaic systems. A paper co-authored by Manasvi Lingam and other researchers explored this concept, suggesting that large-scale solar arrays could, in theory, be detected by future telescopes. With recent enhancements to the JWST, our ability to search for such artificial lights on exoplanets like Proxima b has dramatically improved. Remarkably, in 2024, the upgraded JWST detected what may be artificial illumination, a groundbreaking moment in human exploration. This potential discovery could usher in a new era of space exploration and planetary science. Let's delve into the exciting world of exoplanets to understand how such breakthroughs became possible. Since the earliest days of recorded history, humanity has looked to the stars and pondered our place in the cosmos. Who are we? Where did we come from? Where are we going? These timeless questions remain as relevant and elusive as ever. From a philosopher's perspective, we may still be at the beginning of our quest. But ask an astronomer, and you'll hear unbridled enthusiasm as they share the latest insights made possible through sophisticated instruments, many of which go unnoticed by the general public, yet are profound symbols of human achievement. We now possess tools that allow us to observe the universe in ways once thought impossible. Among the most significant is the James Webb Space Telescope, a marvel of infrared technology designed to unravel some of the deepest mysteries of existence. The JWST embodies humanity's determination to answer essential questions. Are we alone? What is our purpose? Where is this cosmic journey taking us? If you're curious about Proxima b, also known as Proxima Centauri b or Alpha Centauri b, it's a super-Earth that orbits an M-type star. Wondering what a super-Earth is? Don't worry. This article will explain everything. Super-Earths and the fascination with Proxima b. Super-Earths are planets larger than Earth, but smaller than gas giants like Neptune and Uranus. These worlds can be composed of gas, rock, or a combination of both, typically ranging from twice Earth's mass to several times more. Proxima b is one such super-Earth, located outside our solar system, making it an exoplanet. The concept of exoplanets first surfaced in 1917, though it wasn't until 1992 that scientists confirmed their existence, much to the astonishment of the astronomical community. An earlier candidate, spotted in 1988, was officially verified in 2003. As of April 1st, 2024, astronomers have confirmed 5,653 exoplanets across 4,161 planetary systems, 896 of which host multiple planets. Many of these exoplanets orbit M-type stars, also known as red dwarfs. These stars are the smallest and coolest in the main sequence, with surface temperatures around 3,000 Kelvin. Despite being the most common stars in the Milky Way, their dim glow makes them challenging to detect. Proxima b orbits one such red dwarf, Proxima Centauri. This star has a mass just over that of Earth and emits only about 1.6% of the Sun's visible light. In fact, more than 85% of its energy is released as infrared radiation. Proxima b's orbit lies between 0.045 and 0.056 astronomical units from its star, much closer than Earth is to the Sun. It completes a full orbit in just 11.2 days, compared to Earth's 365.25-day cycle. Discovered in 2016, Proxima b quickly became the focus of intense scientific interest. Why? For several compelling reasons. Proximity. At just 4.2 light-years away, Proxima b is the closest known exoplanet to our solar system. While 4.2 light-years is vast by human standards, it's relatively nearby in cosmic terms. Location in the Alpha Centauri system. Proxima b belongs to the Alpha Centauri system, a triple star system that includes some of the brightest objects in the night sky, trailing only Sirius and Canopus in luminosity. Habitability potential. Most intriguingly, Proxima b lies within the habitable zone of its star, where temperatures may allow liquid water to exist. This raises a possibility that it could support life. These factors make Proxima b a prime target for studying planetary habitability beyond Earth. That's where the James Webb Space Telescope, JWST, enters the picture. This powerful telescope has 4 core missions: to observe the light from the first stars and galaxies formed after the Big Bang, to study the formation of stars and planetary systems, to analyze how planets and stars evolve, to search for the origins of life. As JWST continues to investigate exoplanets like Proxima b, scientists move closer to uncovering answers to some of humanity's most profound questions. The quest to explore distant worlds and detect extraterrestrial life is not just a scientific endeavor. It's a testament to human curiosity. Our innate desire to understand the universe has driven efforts like the Search for Extraterrestrial Intelligence SETI, which began in the 1960s when astronomer Frank Drake detected radio signals from stars. While these signals did not yield contact with alien civilizations, they ignited a long-standing scientific mission. SETI is often likened to a game of cosmic hide-and-seek. Earth is listening for any sign of intelligent life across the vast universe. Despite decades of unanswered signals, advancements like JWST continue to refine our search and raise hopes of a breakthrough. Should we discover definitive evidence of extraterrestrial life, it would not only revolutionize science, it would forever change our understanding of life's place in the cosmos. The discovery of extraterrestrial intelligence, or even distant artificial signals or light, would profoundly reshape our understanding of intelligence and the very fabric of the universe. Even in the absence of direct contact, such findings would suggest that intelligent life may be more widespread than previously imagined. The thrill of such discoveries is undeniable, yet they bring with them a host of profound questions. How would humanity respond to the confirmation of life beyond Earth? Would we meet this revelation with curiosity, respect, and scientific integrity, or would it stir fear and uncertainty? History shows that humanity's reactions to paradigm-shifting discoveries, particularly those that challenge deep-seated beliefs, have often been unpredictable. This leads to broader ethical and moral dilemmas. If we were to encounter intelligent extraterrestrial life, what obligations would we have? What moral compass should guide our interactions, whether with microbial organisms or advanced civilizations? These questions are not just theoretical. As our exploration of the cosmos advances, they will become central to how we define our place in the universe. Standing on the threshold of potentially transformative discoveries, the issues of responsibility, ethics, and identity grow more urgent. Encountering alien life of any kind would be among the most significant events in human history. It would upend our understanding of biology, consciousness, and what it means to be human. How we handle such a moment will shape our legacy and influence future interstellar interactions. Beyond ethics, practical concerns must also be addressed. How can we engage with alien life in ways that respect their autonomy, cultures, and ecosystems? Could even passive observation inadvertently harm these life forms or disrupt fragile environments? Human history is filled with examples of well-meaning actions leading to unintended ecological consequences. We must not repeat such mistakes on a cosmic scale. These considerations extend far beyond science. They touch on philosophy, religion, politics, and global culture. Discovering intelligent life would likely ignite debate about whether to pursue cooperation, prepare for conflict, or consider colonization. Would this discovery unite humanity or deepen divisions as different ideologies seek to control the narrative of what such contact means? As we move further into the unknown, international collaboration becomes essential. The search for extraterrestrial intelligence, SETI, the study of exoplanets, and the detection of artificial signals must transcend national interests. Just as the International Space Station has demonstrated the power of global cooperation in space, so too could SETI become a unifying endeavor for our planet. The pursuit of cosmic knowledge belongs to all of humanity and demands a shared spirit of openness, humility, and mutual respect. At the same time, we must be prepared for the philosophical and spiritual upheaval such discoveries could bring. Science, religion, and philosophy may all be forced to re-examine their foundations in reality where humanity is not alone, and perhaps not even the most advanced intelligence in the universe. This would reshape how we define consciousness, life, and community. It could forever transform our understanding of existence and our place in the cosmos.